Welcome to Turn Right Machine Works. My name is Keith, and today we have a modification project on a bronze rudder shaft. And before I get going on this, I would like to say that I appreciate all the condolences and best wishes and thoughts, prayers, everything that's come in for my dad during the time that he was on his last days, and also after passing. It's been a rough year. Between Vanessa's family and my family, since last spring, we've lost 4, including my dad. And also, you know, knowing Adam and him losing his father, and when Adam and I first met through our YouTube there in communication, we kind of talked about being popped out of the same mold, and if that was the case, then our dads would be popped out of pretty close to the same mold as well, because they are the molders of us to start with. And you know, when Adam gave me a text there, and I was just coming out of Best Buy there, I picked up my computer, put back in the plasma cam there, malfunctioning, and I had to pull over because it hit so close to home. Because I just caught a glimpse of it. It says Dad didn't make it, and you know, when my dad fell from the sky, that's when I thought my dad wasn't going to make it. And I did make a trip out, and I got to touch him, I got to hug him, I got to kiss him, I got to tell him I love him. And doing that at that time, and we've always been close, we've been tight. We really know that, you know, nobody's getting out of life alive, and no matter how much you're prepared for it, it's still going to put a pit stop in the race of life. And anyhow, I do want to show my appreciation for all you guys putting that in there. And you know, John from Turbo Boost, you know, saying something, and also Tom giving tribute to Adam's father. Fantastic! All the viewers are fantastic, and of course we're all got our little hiccups here, and we're going to get rolling. All right. With that said, what I have is a bronze rudder shaft here, and it's kind of, I'm going to flip it over here because that was the top, and this is the bottom, and actually the blade bolts to this plate assembly here. And what I have to do here, what they're requiring me to do, is they want to add a bearing, and they want to add that bearing, I guess, somewhere right in here. Okay, now you can see that this is round with a flat bar welded to it. All right, so I'm right here in the middle of this. I'm going to have to create a bearing pickup right there, and we're also going to have to finish machining this support, which this will get split in half and have a bolt pattern that goes like this to sandwich it on the rear of the keel. Alright, so I'm going to go ahead and I got to go in and take a little wire wheel to this just to get some barnacles off of this thing before I can go put it in the Bridgeport vise, and I think we're going to start this project over in the Bridgeport. Alright, so let me go do some wire wheeling, and we'll meet you over at the Bridgeport. Okay, we wire wheeled down each side here. We're going to want to clamp on this, and we're going to use the bottom of this flat bar right here to sit down on top of the jaws of the vise there and support it. Alright, now we've measured from the end and everything, and we got 2 scribe lines right here. So we're going to set this up in the vise here, and we're going to use our screw jack to support this after we get this setting level and we get this underneath there. And that's how we're going to set this thing up square with the table, so that we could come in and we're going to mill out the bar section itself down, but not touching the round diameter. That's going to get rid of this bulk. After that, then we're going to go get this thing in the lathe so that we can finish spinning this diameter. This diameter here is like 1 inch 5/60 or so, and we need to make it 1.5 inches where that bearing is going to be riding. And the print calls this out to be 1.5 inches also. So it just means we're going to give it a couple thousandths clearance. And so we'll have to turn that in the lathe, but we're going to do it after we get this milled out of this side here. Alright, so let's get it on in the mill here. Alright, now we're just going to make sure it rests down underneath here, and basically our cut's going to be out past here. We're rocking it, we're going to hold this down so we know that we're flat against the bottom here. Now we just know that this has got some weight out here, so we're going to put the screw jack underneath this end here and lightly tension it, just so we know that there's no vibration, no chance of that actually dropping. And finish tightening. Alright, we're going to take out our drill chuck here, and we're going to put in an end mill that will let us come in and cut this out. And we're going to go ahead and we're going to get a cloth underneath here because this is bronze. And we collect bronze. We have a turbo end mill, only it's just convenient. Also they make kind of nice chips, and I can go kind of slow and the chips will kind of fall here. They're not going to be the kind that stab you. This is silicon bronze probably, and with the regular end mill they do tend to be real sharp chips. This will make little broken chips more than anything else, easier to catch. I'm going to take the screw jack and put it underneath here, just a little bit of pressure, just so that this is not vibrating out here. Now, looking down the road, when we get ready to spin this in the lathe there, we're going to be holding that in the lathe, and I'll show you how we're going to hold that. But this end right here, we want to run with our center, so we're going to have to do something. We're looking here. Somebody has already munged up the inside bore lip right here at the edge, so we got to think it's doing something. Maybe a disc with a center hole in it, or something that's a little cap that comes over the end. We'll kind of look at that, but we are going to need to support this to turn this. Alright, so we're touched off on our end mill now at 0, and we're going to go ahead and lock our table, and we're just in between our guidelines here. So we're going to come across and we're going to get comfortable as far as the depth, and then we're going to just go back and forth till we come out to those 2 guidelines, or those 2 scribe lines that we put in here. And actually I want to go ahead and make them a little bit more distinct here. Okay, here's our chip catcher, and I'm going to put this back here and up here. Now we're going to go ahead and we're going to grab a couple magnets that we like to use so that we hold our catcher in place here. And we're going to go ahead and we're going to put one over here and probably another one over there. There we go. Okay, we're good to go now. Alright, now we're just going to feed her down, and we're going to go ahead and let's see what we actually, I thought it was 1/2 inch. I just want to make sure, and it's not. It's actually 7/16 material. Okay, that takes us down about a 32nd of an inch left. That actually cuts more like naval brass than it does silicon bronze. We come down to where we're just razor thin skin down there at the bottom that shows that we're not quite all the way through, but it's like paper thin. So we're going to go and we're going to get our thickness out here first. come down here and you can see we're razor thin. You can hear how tinny that is. Actually, if I took a hammer I could dent it down. But I'm going to come in here with a hand grinder now, and I'm just going to knock this off of here so it's almost all round. You can see where this is peeled here. Underneath this bar, the length of the bar was slightly milled flat. You can see that down at the pintle support, which we'll be looking at that closer later. So we just lifted. So there's the shaft material right there, and it's still got its tarnished surface on it. So we haven't gone anywhere down below that surface right there, and the rest of this here will come off when we turn, because the welds and this diameter is going to actually be reduced by 25 thousandths per side or so, 25-30 thousandths from our miking of the shaft diameter and what they call out for a bearing diameter. So we're out to our scribe lines and we're all good for our operation here. We're going to pull this out and get it on over to the lathe. Now here's kind of the beauty of using the turbo mill, even though it's not a hard material and we're not hogging up a whole super bunch of material there. We still have a nice manageable chip. These aren't sharp, they don't go into your hand. Of course, we thought this was going to be silicon bronze. We weren't sure what that material was going to be. And by going ahead and actually even bronze will have somewhat magnetism to it sometimes when they're cut and they're shaped. So even the scrap man sometimes will pass off as magnet through bronze. And he's going to try to knock you down on your price there. And it's still worth every bit of money that bronze is supposed to be worth. And it's not that you have steel mixed in. The actual chip itself will stick. Okay? Just keep that in mind. It's hardly, I mean, it won't like pick it up and jump like steel will. But if you stick it right down in there and go like this, they'll go, hey, you got steel in there. Okay? Just keep that in mind. It's not that you have steel in there. There is magnetic particles or alloys in the bronze itself. There always will be. We're getting ready to take our bearing support in and give it a quick sand so that we know that it's parallel and smooth, because we're going to be clamping this into the vise. We have a series of holes that are going to go through this, and they're going to be countersunk on this side, and they're going to be threaded in on this side here. After we have those 3 holes drilled, tapped, and countersunk, we're going to be splitting this direction here. So after we sand this, then we're going to go ahead and we're going to put 2 parallels here, and we're going to scribe in 2 cross lines here and here to create a center line that will scribe. And then that scribed center line will let us set this part exactly horizontal. We'll come in here, we'll do our holes, and then we're going to hold this thing up, and we're going to take a slitting saw and we're going to machine that split line at the same time of cutting that line. So we don't have any machine work after that except for to put it back together with our bolts here and bore this out for the finished diameter. It's kind of our plan. So we're going to take this in, we're going to go kiss off the surface here with the belt sander, and we'll be right back. Alright, I got a nice fresh belt on here because I don't want to be spending a lot of time doing this. Not that we have any big dimension difference here. We want this to be parallel. The angle arc vise does compensate side to side a little bit narrow, and you can get the tension that you need, but I want to absolutely make sure that this thing doesn't come loose, so I want it as parallel as I can. Alright, so we're measuring up here, and we got like 479, and we got 475 here. We got 1.5 there, 1.5 there. Okay, so it's pretty even here to here. We don't actually have to do too much. As long as we can maintain that, we'll set up on this side right here. But we're hitting here, 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 there. You can see a little bit difference here and here. Now this 5, we want to be looking at that to get most of that down, and it is grabbing quite a bit there in the little spot right here. And we're going to see if we can get this a little bit more uniform, not so hollow in the middle here. Because we only have 6 inches that we're going to be grabbing here. We want to have that as firm as possible. Just a little hollow there and a little hollow there. I'm not too worried about being in the middle there. We still got to split it. Alright, let's hit this side. Pretty good hollow right here still. Alright, let's check our dimensions. Almost the same there. Almost the same there. We are holding parallelism. We're a little narrower on this side than we are on this side here. We're just applying pressure on the area that we think we need to concentrate on to make it more even. We are closing down. There's 450 there, 458, 460, 458. Alright, we're gonna be using this side to clamp, but we got a little raised area here. So we're just getting that off. Alright, we'll hit this in here with a little file, just to break that edge there. We'll go ahead and take some Sharpie, we'll paint it on here, and we're going to get a scribe line set up in here. We'll go ahead and get it in the mill vise, and we're going to lay out these 3 lines here, 3 positions for the flatheads that we're going to put in. Now we're going to drill through, and we're going to drill down relief for the bolt, and then drill tap diameter for the bottom. This will be through hole, countersink, tap down here in the bottom. Same thing right there. 3 holes. We're doing a little grinding here. Of course, I disconnected this, just put a little bit of oil in this. This is one of my most favorite pneumatic tools I think I've ever used. And of course, everybody likes cut off wheels and different designs. And I don't think anybody can beat this design. This was made by Mac Tools, and I think I got this back in 86, 87, somewhere around in there, and it's still going to this day. One thing that's really unique about this is you can pull this out, and this can be swivel up or down, and it really helps out a lot. This guard, the very first job I had, I dropped this thing and broke the guard right off of the base, and then that was back when I was learning how to heliarc, and I was actually able to heliarc that, and to this day my weld is still holding, and I've dropped this thing many more times than that just once. And this thing does shit and get, you know. This guard is one of the few tools that I really do, and I actually hang on to this guard a lot to really give finesse into the grind. And lots of times you want to come on over something like this, it is really handy. Very seldom do I use it in a straight position. I'm either out or cocked the other way. Okay, all I'm doing is knocking that little bit of weld right there, so I don't have so much material to remove once we get this spinning in the lathe. Alright, now I'm going to go ahead and I'm going to rotate this. One thing nice about this guard here, the debris does go off that direction there. So your viewing side is always comfortable. In fact, I'm going to bring you around. Okay, now that we've knocked off most of the flashing, that's about as thick as that was that we left on there after the mill work. Alright, this will be ready to go in the lathe. Alright, so we're going to set this up in the lathe and get spinning on it, and we're going to go ahead and set up on the bearing support, and we're going to get that going at the same time. Okay, our final test, if we got a good hold here, is to go ahead and just hold this in the vise here, wiggle it just a little bit here, and lightly tension it. And if we can't pull this up and down, and we know that one side of this is not being held any tighter than the other side of this, and we have a good straight and even uniform grip on it. Okay, so now that we're going to be happy with that, we're going to go ahead, we're going to take our Sharpie and create a layout line that will be center with this part. To create a layout line on here, we're going to take two parallels that just lightly stick up past the surface here, and we'll go ahead and take a clamp on here. As long as they lay flat in here, we're going to be fine. And we'll take this side here and we'll do the same. Alright, I'm happy with that. Now, the reason why we put these on here is they're going to be two guides for our dial scribes here. And just want to make sure we're calibrating our scribe. There we go, we got 0 on that one. Alright, we're gonna take an area right across the center here, and we come up with 2 inches 365. Okay, so we're going to take 1 inches 150 or 150, 180, 183. All right, that's going to be half of that. Now we go ahead and scribe parallel to this surface here, so trying to hold it 90 to this surface and hold it 90 to this surface. We get 2 lines. Alright, I'll bring you in for a close shot as soon as I do this one. Now we're going to go ahead, we're going to take this one, and we're trying to get right across here in the middle, right there. Okay, 2 180. So that would be 1 90,000. Same thing. Alright, let me bring you in close so you can see that. These two lines intersect right about there, midsection. And these two lines are shorter and everything, but they also intersect about right there, midsection. So now what we do is we take our pocket scale, and I like to take my point and put it right down on the line at that crisscross so I can slide my scale like that. Oh, once you have picked your cross hairs, you put in a hard scribe line right there. Okay, that's going to be the split line. There we go. Alright, now that we have that split line, we'll be able to set this up in the vise to go ahead and do our 3 holes and our slitting saw.